In 2022, an unlikely association of fossils were discovered in the Hell Creek Formation of North Dakota. This football-sized block of rock contained a T-Rex tooth, the jaw of a crocodilian, and, remarkably, a tooth from a mosasaur, all in an area already known for its abundant hadrosaur remains. Now, mosasaurs are very large aquatic predators, and this tooth was identified as coming from a prognathodontine, which allowed for a size estimate of around 11 meters or 36 foot in length. But in the late Cretaceous, this site has been interpreted to represent the floodplain of a river. So, how did the fossil of a giant marine reptile end up on a riverbank in North Dakota? Answering this question was only possible because of how the fossils were found together, in the same place at the same time. Because they shared the same 66 million year history, from death to discovery, the chemistry of the fossils can be directly compared with great confidence. This is done by analyzing the isotopes of different elements within, since knowing what a fossil is made of can tell us a lot about how and where it lived. To give just one example from the study, the ratio of oxygen isotopes can be used to tell us about the water in the environment in which each animal lived. The most common isotope of oxygen has 8 neutrons and 8 protons in its atom, giving it a mass number of 16. A rarer, heavier isotope has 2 additional neutrons, giving it a mass number of 18. When water evaporates, it is more likely to contain the lighter oxygen 16 than the heavier oxygen 18. This means that freshwater, that rains down filling lakes, streams, and rivers, contains relatively less of the heavier oxygen 18 than seawater. When comparing these oxygen isotopes within the fossils, it was shown that they all had relatively little oxygen 18. And this is the same conclusion reached by separate analyses of strontium and carbon isotopes. These multiple lines of chemical evidence combine to prove, for the first time, that mosasaurs were capable of living in freshwater environments. So our tooth isn't actually out of place at all. The results mean we have to review mosasaur paleoecology, reconsidering where and how they lived and how they interacted with other animals. We also really need to reassess just how scary it must have been to approach the waters that flowed through the Hell Creek Formation.